Today we're taking notes on 9-1 properties of radicals. This is the second day of 3 days for this section in notes. The key vocabulary for today is rationalizing the denominator. This happens when a radical is in the denominator of a fraction. You can multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. If you can remember from your notes from yesterday, one of the rules to simplifying radicals is that you're not allowed to have a radical in the denominator. So I'll show you how to rationalize that. Okay, and then conjugates. They're used to simplify radical expressions that contain a sum or a difference involving square roots in the denominator. Example 4, rationalizing the denominator. When you look at this, we have the square root of 5 over the square root of 3n. So neither one of those are perfect squares, and you're like, it's pretty simplified, like I don't know what else to do, but the problem is you are not allowed to have the radical in the denominator. So in order to get rid of that, if you think about it, square roots need pairs. Well, let's give it another 3 in n under the radical sign. But if you're going to multiply that to a fraction, you must do it on top and bottom because essentially right here, this is equal to 1. So when you multiply anything to 1, it just stays the same value. So now let's look at this. When you have radicands, so numbers underneath the radical symbol, they can be multiplied together. So technically, this is 5 times 3 times n, which equals 15n on top. On the bottom, and eventually you won't have to write it out this whole long way, but you have 3 times n times 3 times n. So that's equal to 3 times 3 is 9, and n times n is n squared. So the square root of 9 is 3. The square root of n squared is n, because remember there's a pair. N times n, it comes out if there's a pair, and it comes out as 1. Okay. On top, there's no pairs because 5 and 3, that's not the same number, and there's only one n. So you'd have to leave this in the radical symbol. But that's rationalizing the denominator. For letter R, we have 2 over the cube root of 9. So this is a little bit different thinking than your previous example because we have a cube root instead of a square root. When I think of this, I think of, okay, the cube root of 9 is 3 times 3. I need to have triples. Right now I only have a pair. So to get this to be a triple, I would need to multiply this by another 3. But in order to keep the value the same, I would have to multiply the same thing on top and bottom of a fraction. Okay, right now 2 is on the outside. It's not inside the radical symbol. 3 is inside. So when you multiply 2 times the cube root of 3, they don't combine with each other, or they come together, but they don't both go inside the radical or stay outside the radical. 2 stays outside by itself, and the cube root of 3, that stays inside the radical by itself. Now, since 9 and 3 are both inside the radical, everything can come together inside. So we have 9 times 3 essentially, which 2 cube root of 3 on top. Cube root of 9 times 3 is 27, and the cube root of 27 is 3, which is perfect because now we've taken the radical symbol out of the denominator. All right, next one. These get a little bit more complicated. I'm going to actually show you something at first. If you want to write it down, great, but I'm not requiring you to. But when you look at this, and if I didn't teach you at first and said, hey, simplify that, some of you may say, well, let's multiply it by square root of 3 because that's pretty much what we did in the first example, for example 4. But the problem with this is when you just multiply by the square root of 3, if we were to distribute this, okay, the goal is to get rid of the radical symbol in the denominator. We now have 2 root 3 minus the square root of 9 in the denominator, which equals 2 root 3 minus 3. So yay, we got rid of it where it originally was here. But now this one, we added a radical symbol. So that did not help get rid of the radical symbol in the denominator. So what you're going to do to get rid of it is multiply top and bottom by the conjugate. And the conjugate just means this. We're going to take 2 minus the square root of 3, and we're going to multiply that by 2 plus root 3. So the conjugate means we take whatever the expression is, but we change the symbol in the middle. So if it's subtraction, it goes to addition. If it's addition, we're going to do subtraction. Again, if we do that on the bottom, in order to keep the value the same for the fraction, we must do the same thing on top. Now, let's see what happens on bottom. We're going to have to FOIL here. So 2 times 2, that's going to equal 4. 2 times square root of 3 would be 2 root 3. Negative 3 times 2 would be negative 2 root 3. And then negative root 3 times positive root 3, and negative times a positive is negative. Root 3 times root 3 is root 9. And some of you might say right away, well, that's just going to be 3. So the reason why you multiply by the conjugate is because this happens. We have positive root 3, take away, or sorry, positive 2 root 3, take away 2 root 3. So that eliminates that in the denominator. So essentially we just have 4 minus 3. Oh, that's lovely because we end up with 1 on the bottom. No radical symbols. That's the goal. Now for the top, for the numerator, we need to distribute this 7. So 7 has to go to 2 and 7 has to go to root 3. So 7 times 2 is 14 plus 7 root 3. And that would be it. So 14 plus 7 root 3, that's all over 1. We don't need it to be over 1. So your final answer would be that. Next one. This one has a plus sign. So the conjugate, you're going to keep everything the same. The only thing you're changing is whatever symbol that is. So we'll keep it as root 2 and root 7. But this in the middle needs to be the opposite. So we're going to subtract. We're going to do the same thing to the top. So we'll have root 2 minus root 7. And let's do some FOILing on the bottom. So root 2 times root 2 is going to be the square root of 4. Root 2 times negative root 7 would be negative root 2 times 7 is 14. Positive root 7 times root 2 would be positive root 14. So these two are just going to cancel. And then we have square root of 7 times the negative square root of 7, so negative root 49. These simplify. Square root of 4 goes to 2. Square root of 49 goes to 7. So these symbols are gone. We have 2 minus 7, which gives you a negative 5 in the denominator. Great, we've done our goal of getting rid of the radical symbols in the denominator. Now on top, let's distribute the 12 to root 2 and negative root 7. So we get, I'm going to move all the way over here, 12 root 2 minus 12 root 7. Okay, and for that, let's rewrite it down here. When you look on top, they are not like terms because these two are not the same radicand. So we can't combine those. So we'll just keep them as is. And then on the bottom, we have negative 5. I'm okay with this as your answer. The only time you're going to simplify is if the numbers outside your coefficients all had something in common. 12, 12, and 5, there's nothing that can go into 12 and 5, so we can't simplify. But if this had happened to be 12, 12, and 6, we would have simplified the outside numbers, the coefficients. Okay, so this is your answer, simplified. Example 6. The distance d in miles that you can see to the horizon with your eye level h height above the water is given by d is equal to the square root of 3h over 2. Find the distance that you can see when you are 5 feet above the water. You are literally just putting information in, okay? So the distance d in miles. So distance for d. H is the height. All right, in feet above the water. They give us this fantastic d equals square root of 3h over 2. And then we're also given 5 feet. Well, you need to understand, what is 5 feet? Is that going to be d, the distance, or is that your height? And it says, find the distance. So that means we don't know what that means. We don't know what that is. That you can see when you are 5 feet above the water. So this is going to be your height. So that should go into h. So d is going to equal to the square root of 3 times 5 over 2. Let's break this into two smaller square roots. So we have square root of 15 on top and the square root of 2 on the bottom. Cannot leave a radical in the denominator, so we'll multiply it by square root of 2. Since it's a square root, we just need to double the number. On top, we have the square root of 30, which is 5 times 3 times 2, and there's no doubles there. There's no pairs, so that's not going to be able to be simplified. That is simplified, nothing further. Square root of 2 times the square root of 2, well, that would give you the square root of 4, which is 2. And that is your answer. And you can write miles. It doesn't ask you to round it, but if it did ask you to round it, let's say to the nearest hundredth, you would just put that into your calculator, the square root of 30 divided by 2, and that is approximately 2 74 of a mile. So that's how far you can see if you were 5 foot tall above the water. I also want to mention that if you need further guidance and you want to see more videos, if you go to your big ideas and you click the student dynamic ebook, so right there, click that. This will take you to your textbook essentially. So I always click on contents. I go to chapter 9 that we're in, or whatever chapter you need to find. And then in this chapter, we are on section 9.1, properties of radicals. So then it brings you to the beginning of it. Today we did examples 4, 5, and 6. So you can find examples 4, 5, and 6 in your textbook, and next to them you'll see that there's a tutorial button. If you click on that tutorial button, it brings up another video with different numbers that you can watch. So that, and it's somebody else explaining them, but that might be helpful. And you could do this at any time. If you needed to go over notes from yesterday's, watch some more examples from that, you can go and look at the tutorial next to examples 1, 2, and 3. I just wanted to give that option to you. So all these blue play buttons are videos that you can watch for additional help. This concludes your notes for section 9.1 day 2. You are now going to work on big ideas, 9.1 day 2.